So, hello guys, this is Icafee. So, I'm just going to explain the analysis of diseases on nails using just feature extraction. So, this is the paper or the idea what we have. So, just let's quickly proceed into it. So, main agenda of this presentation is to give introduction and what is the present existing gap, what we face in the present current world. So, and then the system design what we have and go into the implementation directly. So the introduction. So the present current world has a high level machinery and qualified surgeons to detect diseases, but we don't need all these things. We just need a simple image processing techniques to detect some particular diseases. So without any lot of effort, we can just detect some basic diseases for a particular person, so that the particular qualified surgeons can go to some high level diseases and cure them easily. So this particular basic diseases doesn't even need some man effort. That's what our main intention is. So the model what we have just takes a normal nail image input of a particular person, and just the output just gives the disease, a small particular disease of a particular man if he's having it, based on the input of the nail. So the system architecture directly tells you that you need a nail image. So I'll just show you the uh, repository what we have. So this is the nail images what we have. So this is all the nail images, the normal simple nail image, all you need. So it takes the nail images, and now we pre-process the nail images, and now using just GLCM module, which is gray level co-occurrence matrix, uh, and taking the percentage of RGB values of each particular nail image. Now we can just get the features of it, and then analyzing what we got from the reference materials, which I'm just going to show you in the future. So we can predict that this particular model works fine. And for just software requirements, simple software requirements, we just need a MATLAB just to extract features, few image processing techniques, and then VCA tool just to measure the percentage of accuracy. It's not mandatory for us to use VCA tool. Here we are just using VCA tool to present to measure the accuracy percentage. Uh, so directly diving into the so-called model. Uh, First, we are taking the main images. We are taking the percentage of RGB values, which is the red, green, blue percentage values of the particular nail image. Uh, from the reference what we got, as I said, if a particular nail is so whitish in color, we can just tell that a particular person has cirrhosis or kidney problems or anemia. Or if a particular nail is so yellowish in color, we can just say the particular person is having nail fungus or diabetes, which is so common problem, and even jaundice, which is so common problem. The same thing goes with texture analysis. We are just processing all the nail images what we have, and using the library of gray level co-occurrence matrix, we are just taking four features or attributes, which is contrast, correlation, energy, and homogeneity. With these attributes, we can just say if a particular image is having vertical lines, we can just say it's having kidney problems or calcium deficiency or bronchitis or something like that. And if a particular nail has white spots, if it is significant to see in that particular nail, then we can just say it's having calcium deficiency or vitamin A deficiency or something like that. So this is our proposed model, and now with the analysis part, we are just going through multi-layer perceptron algorithm. So I'll just directly dive into the MATLAB thing, and I'll just show you the uh, implementation or the working part directly, so that you'll just understand it as I further proceed. Now, so this is the code what we have, and in the code we are just directly taking the repository path which I have set you. So this is the repository, but here we are having 93 images. So I'll just show you. So for some 15 images names, so 15 nail images. So that it will be easy to understand for you, and then I'll predict that for the 93 images names. So the only thing why I'm doing this is MATLAB takes lot time constraint, so it will be easy for you to understand just by showing it for 15 nail images. So this is the 15 nail images what you can see. So I'm just setting that path for it. Now I'm just running for every nail image what we have, if it exists. So now with the gray level co-occurrence matrix and RGB values, first I'm just setting the texture of everything. So I'm just getting the contrast attribute, correlation attribute, energy attribute, homogeneity attribute, and getting into the different columns. And then with same goes with the RGB thing. So with taking the RGB values, I'm taking the average or the mean RGB value for yellow color, percentage of yellow color, green color, and blue color, and I'm taking that values in each and every column. So just running this code. So you can just see the nail image what we have was a bit normal nail image. Here we are just zooming it so that we get the clear white spots or the lines or white, green, yellow, percentage of yellow, green and blue values clearly. It will be easy for us. So just showing the zoomed image. I'm just closing it off. All the 15 images I've just closed it off. So that's all what I said. Now the average values what I said, I'll just show you that thing. So this is what we got, the average percentage of GB value for every nail image. If you consider this first nail image, this is the percentage of RGB value for it. And if you consider the second nail image, that's the percentage of RGB value for it, and so on and so forth for the next 15 images. So the same thing goes for texture thing. So these are the texture thing, as I said, the contrast, color, white attributes for the same images. First, for the first image, the attributes are corresponding, and for the next images, the attributes are corresponding. Now, this is how we are extracting the RGB values, and as well as the color, contrast, and correlation, energy, and homogeneity attributes correspondingly. So sorry for the interruption before. So yeah, let's continue. So as we run for the 15 images what I showed you before, we are just getting the texture values, and as well as the percentage of RGB values for every image. Now the same thing we have run it for the whole nail images data set what we had, the 93 nail images data set. Now after running the 93 nail images data set, we have exported the texture values and the percentage of RGB values accordingly into a CSV file. You can just see it, the percentage of RGB values of the first image, second image, and the third image. Now the last thing, or the last column what you are seeing over here is the label. If the label is 1, it may have the yellow color, and if the label is 2, it's normal. Something like that we have assigned for the every label. Now the only thing what we are doing in our project is the analysis. whether the particular thing what we referred is it right, and so that the model can be implemented easily. That's what is the main topic or main intention is. So this is for the color thing we exported, and the same thing we exported for the segment, the contrast, correlation, energy, homogeneity have values also, the texture attributes, and we have assigned the labels accordingly. So if a particular nail image has vertical lines, we have mentioned it as a schedule. Uh, if a particular nail image has vertical lines, it has some particular disease. If a particular nail image has white spots, it has some another disease, particular some particular other diseases. So accordingly, one label if it has vertical lines, two label if it has white spots, and three label if it is normal. So in that way, we have the texture part thing also. So for the analysis part, as I said, we are using Vika tool. We can just use any other uh, analysis software. Easy. So as this is simple and easy, I'm just using this Vika tool thing. So I'm just setting the path, opening the file what I have just showed you before for that 93 nail thing, 93 images of nails. So this was the color thing. So I opened it. The percentage of RGP values and the label. So these were the four attributes. What you can just see, it has just loaded it. So just by classifying I'm just using the multi-layer perceptron algorithm. You can just use any other thing. So keeping the percentage split for it as whatever. I'll just keep 75. So we are splitting 75% as trained data set, and the other 25% is just for using test. So there's the color thing, and started. So after running the multi-layer perceptron algorithm, you can just see the other 75% has been trained. So the left 25% with are 23 instances in from that 93 images. So in that 23 instances, we are getting 17 instances as correctly classified instances, and 6 images were incorrectly classified. So 73% is the percentage of correct accuracy for what for the model what we have. So if that percentage of RGB values is low accordingly or normal, we can just directly detect the disease, small common diseases with 73% of accuracy. So that is all what we need when we are detecting a disease. So the same thing, I'm just going through the texture analysis thing. So uh, just opening it. I'm just opening the segmentation part file, the ARFF file. So Vika tool needs ARFF file. It doesn't support CSV file. So you just need to add attributes. I'll tell you how you need to add that. So considering this as the segmentation file, so the contrast, correlation, energy, homogeneity, and the label attributes. So you just need to refer the attributes and directly the data as CSV file what we have, the comma specified termination, comma termination. So just need to mention the attributes that becomes the RFF file for the VCAT tool what you need. Uh, the same thing, we can use multi-layer perceptron again. You can use anything what you can use anything what you want. Over here we are just using multi-layer perceptron. Multi-layer perceptron basically is a back layer propagation algorithm. So it classifies uh, back layer on propagating back layer. So propagating backyard. So keeping percentage split as 75 or 80, whatever. So 75% or 80% is the training data which is split, and 20% is the test data. So you can just see you're getting 72% of accuracy for the texture thing. So if a particular nail image has vertical lines or white spots, you can detect with this particular label or one label or then the two label. And if it is normal, you would just labeling it as three, normal, three, two, from the nail images what we have. So accordingly, you can just say or tell that it was just uh, showing you 72% of accuracy with the model what we got from the reference. Uh, that's how, yeah. So that's how you can just tell uh, the model is giving you approximately 70 plus accuracy with the analysis what we got just by taking the nail image and getting the percentage of our red, green, blue values and the texture analysis accordingly detecting the disease or telling that the person is normal. So just showing you all the things we have run into multi-layer perceptron algorithm as well as for the color and for the texture, and the same thing we have run it for lazy k star and the lazy k star for texture. This is another algorithm. You can run it on any other algorithm on your concern. So the final result what we can tell you is that we can detect a particular mm, disease of a nail directly just by analyzing or seeing the nail image of a particular person. We can detect some diseases, and this is so cost effective and time effective, and also it's reducing the manpower. You for some diabetes things, you are just taking blood samples and going through high level machineries analysis and then detecting things. So something like jaundice, you can just tell that you have detected for that particular person is whether he's having jaundice or not. So the references, as I told you, this were the references what where we got that a particular disease, a particular nail is having particular disease, whether it's having a particular disease or not, just by the references we have got, and now we had analyzed and telling that with a particular accuracy that yes, we can truly go with this analysis and detect that whether it's having the name in disease or not. So yeah, that's how mm, we have completed our presentation. Hope you had a good time. If you have any Q&A, you can just comment down. Thank you.